Welcome everyone to the presentation of Puro.earth's BECCS and geologically stored carbon methodology. We're very happy to have you today. It's a really proud moment for us after many months of this work group's effort that we can present this to the world. So today we will have this is our agenda. First of all, I am Elba Horta. I will be your host for today. I manage business development and communications at Puro.earth. And we will be followed by Mark Preston Aragonés, a policy advisor from Bologna. He will be giving us a definition of carbon removal. Then Marianne Tikkanen, co-founder of Puro.earth. She will be the one explaining the methodology. And then we will have a Q&A panel with experts from different CCS variants, as you can see here. Actually, I will describe the companies and projects a little bit in more detail just before the Q&A panel. And now I would like to, Marianne, if you can, I would like to just talk a little bit about what is Puro.earth, as some of you may not know so much about us. First of all, we are focused solely on engineered carbon removal. So Puro.earth is a B2B marketplace, standard and registry for carbon removals. We call them CO2 removal certificates or CORCs. Our mission is to help voluntary corporate buyers mobilize carbon removal at an industrial scale. So we provide carbon removal as a service by identifying projects, by verifying them, by issuing the carbon removals, and by helping buyers create a long-term procurement portfolio to be able to reach net zero. We aim at climate and economic impact, and so we are driving forward a global market of carbon negative industries. And we do this by enabling a new revenue stream to help them scale. Marianne, if you can continue with the next slide. Soon we will be launching the comprehensive carbon removal funding framework. This more information on this will be coming in the spring, but I can tell you now that this framework will enable take-off agreements to further accelerate access to capital for carbon removal suppliers. It will include a tradable security called a pre-cork, also an equity fund, and a global network of lenders. More information on this can be given by Antti Vihavainen, one of our co-founders. You can email him at antti@Puro.earth, or you can just contact us at contact@Puro.earth for more information on that. And I think without further ado, we are now going to give the presentation to Mark. Just a brief description of Bologna. Bologna Foundation is an independent non-profit organization, was one of the first NGOs to begin championing CCS and bio-CCS 2 decades ago. They continue to do so through collaborative platforms and research projects. And Mark is going to talk to us about the definition of carbon removal. Thank you, Mark. You can take the floor now.
Thank you, Elva. Just trying to share my screen.
Screen is showing, and also your video picture is showing.
All right. So there we are. Great.
Yes.
Thank you for the introduction. So my name is Mark Preston Aragonés. I'm a policy advisor at Bologna Europa. We're, as Alba just said, we're an independent international NGO, headquarters in Oslo, and we have a few offices in Russia and one in Europe, in Brussels, and a growing team around Europe. And indeed, we've been championing CCS for quite some time. I believe we're one of the first NGOs to have mentioned bio-CCS. We included them in one of our modeling exercises back in 2008. And we've been developing the concept of shared European CO2 transport and storage infrastructure, as you can see on the image here on the right. And so today I'm gonna present to you some principles for how carbon dioxide removal should be understood. But first, I'm going to explain a little bit on why this conversation is important. So these are the 4 reference scenarios that we used in the IPCC special report on 1.5 degrees. And anything that you can see below the 0 line is negative emissions. So essentially when you are taking CO2 away, or greenhouse gases away from the atmosphere and putting them somewhere else. And depending on the way that you reduce your emissions, then you need to deploy more or less CO2 negative emissions. So the scenario on the left is a scenario where we reduce emissions very, very rapidly. And it also includes a bunch of other sort of societal changes. Whether or not they're realistic is another question. And then on the far right is the other sort of side of the spectrum where we delay our mitigation, and then that requires substantial deployment of negative emissions, almost to the order of 20 billion tons of CO2 per year, which is a significant amount of negative emissions. And the reason this conversation becomes important is because, in all likelihood, there will be a limit on how much negative emissions we can actually deploy. In fact, we're working in a project with Fabian, who's also on this call, to try and understand how much we can realistically deploy by 2050. And that might be able to inform us a little bit better on how much we need to reduce our emissions in the first place. So very much changing the conversation from how much do we need negative emissions to how much can we realistically deploy. And that helps us to really understand how much how much emissions need to go down in the first place. Here are the principles that we have been using to sort of constrain the conversation of carbon dioxide removal so that it only includes carbon dioxide removal. We've heard some weird claims of what is and what is not carbon dioxide removal, and we believe these principles narrow down the definition very well. So the first principle is that carbon dioxide removal must be physically removed from the atmosphere. So this implies active removal, an effort to actually remove CO2 from the atmosphere. Second, that the removed carbon dioxide is stored out of the atmosphere in a manner intended to be permanent. This is arguably the most important part of carbon dioxide removal, and it's also the most challenging. And in this respect, this is where carbon capture and storage can play a significant role, because you're taking CO2. We have been taking CO2 out of geological stores to put it in the atmosphere, and now with CCS, with bio-CCS, we'd be doing the opposite of that, putting it back into geological storage, which is most likely to be the most long-term type of storage we can expect. The third principle is around the accounting of how carbon dioxide removal should be understood. So when you're looking at a carbon dioxide removal method, you need to look at the upstream and downstream emissions. So the third principle is upstream and downstream emissions associated with the removal and storage process are comprehensively estimated and included in the emission balance. And then the fourth principle really just wraps everything up nicely. The total quantity of atmospheric carbon dioxide removed and permanently stored is greater than the total quantity of carbon dioxide equivalent that is emitted to the atmosphere. And essentially what this means is, has your process resulted in less CO2 being in the atmosphere after you've done your process? So these are relatively straightforward principles, but they are quite complicated when you go into them. So the first principle, how you might be able to meet this, is through direct air capture, for instance, or through the growing of biomass. There are other methods that might exist, such as ocean, but this is also a very nascent field, so more methods might arise in future. But at the moment, these are the two sort of the two most common forms of removing carbon dioxide from the atmosphere. ways of storing carbon dioxide that we know of. Here are 3 examples. So on the left is geological storage. In the middle there's soil, which isn't quite equivalent in terms of the durability. There are high risks of reversals, etc. But in terms of the scale, it might be significantly larger. And at this stage, there are many questions, many unknowns. But what we can already say is that CCS is very likely to be more permanent than soil could be. It's always hard to use the word more permanent, but unfortunately, this is where the conversation stands when it comes to carbon removal and storage. And on the right, you can see a forest and long-lived forests. And there's always these questions when it comes to natural solutions on the risk of reversibility with increasing climate impacts. There might be more forest fires, droughts, etc., which would then kill the biological matter and re-emit it back into the atmosphere. So the third principle about including upstream and downstream emissions is very important. So this is a diagram taken from the academic paper that we have taken the principles from, and it shows the importance of doing a full assessment of a process to consider whether or not more CO2 ends up in the atmosphere or not. If we take the shortest possible view, then it might look very carbon negative. But if we take the widest possible view and we potentially include indirect land use change, which is hard to quantify, but impacts can be huge, then it can be a process that looks carbon negative if you shorten your LCA, your life cycle assessment, might suddenly not look so good. And so it's extremely important that when you're assessing whether or not a process is carbon dioxide removal, that you take the widest possible lens to determine whether or not you actually are removing more CO2 from the atmosphere or not. So how does this apply to CCS? Well, CCS on its own is not a form of carbon dioxide removal. It is simply just a form of mitigation of emissions abatement. So on the left is what we'd consider to be a typical activity that happens today. So we take CO2 out of geological storage, we combust it, and then the CO2 goes straight into the atmosphere. So as you can see, principles 1 and 2 are not met, and it results in a carbon positive, effectively. Then if we were to add CCS to that facility, then we would capture the CO2, put it back into geological storage, so that we meet principle 2, where we store CO2 in a manner intended to be permanent, but the fossil CO2 is still being used. So this essentially is carbon neutral at best. Of course, in practice, there will always be a marginal amount of CO2 that cannot be captured or that might leak at some point in the transport. But this is the way to understand it easier. And then if we were to source the CO2 from the atmosphere instead of from geological storage, then that's when CCS can become part of a carbon dioxide removal process. So here on the right, as you can see, CO2 comes from the atmosphere through the growing of biomass, for example, and then it's used in a facility with CCS. We capture the CO2 whilst producing something, and then that CO2 is now stored. You then store that CO2 in a geological formation, and you have a neatly arranged carbon dioxide removal process. There are other processes as well, and this is how they might look. This is taken from a report that we wrote with the Zero Emission Platform, which champions CCS and is the technical advisor to the European Commission on how to deploy CCS. And so these are the other forms of carbon dioxide removal that we mentioned. Direct air capture with geological storage being one that is addressed in this methodology. And biochar, I believe, being another method that Puro.earth is also looking at. So what are the takeaways here? Well, carbon dioxide removal is distinct from emissions reductions. This is very important. It's sometimes misunderstood. as being the same thing or a replacement, you know. So carbon dioxide removal is when you're actively removing CO2 from the atmosphere and you're putting it somewhere else for a long, long time. And it doesn't have to be geological formations. It can be in the oceans. It can be in nature, but it needs to be for a long, long time. The second point is that carbon dioxide removal is supplementary to mitigation. It's not a replacement for it. In the vast majority of cases, it will be easier to not emit in the first place than it will be to emit and to then clean it up. An example is that the CO2 in flue gas is significantly more intense than it is in the atmosphere, more present. So it's much cheaper to capture from the flue gas than it is to capture from the atmosphere. That's one of the challenges with direct air capture. And thirdly, the point is that carbon dioxide removal will be limited in supply rather than demand. And we can see this by the increasing amount of net zero pledges by companies. So, of course, this is where Puro.earth comes in, and this is something that we will need to work on in the lead up to 2030, when we really need to start ramping up the deployment of carbon dioxide removal as a supplement to very rapid and deep mitigation. So that's my presentation. Thank you very much for allowing me to present this.
Thank you, Mark. Now we will have Marianne with the methodology.
Yes, thanks, Elba. It's uploading here. So my name is Marianne Tikkanen, and I am a co-founder of Puro. Have been with Puro from the beginning, but Puro itself is not very old. So let me tell you a brief history of Puro. So started in 2018 with an aha moment of our colleague Antti, who came to realize that carbon removal is possible. Carbon can be removed from atmosphere, but it's for some reason not happening. And a business model is missing why anybody would do it. That's where the concept of Puro.earth started. And during 2019, we did market validation. With the 22 companies, we co-created the 3 first removal methodologies for biochar and 2 types of durable building materials made out of biomass or made out of mineralizing carbon dioxide to carbonates. And during that year, we were able to demonstrate that verification of these removals is possible and the sales is also possible. We had our customers, Tieto, SCB, and Swiss Re, the pioneers that year. Then 2020, we grew from there with new customers like Shopify and Microsoft, and started to create the next methodology, which is this geologically stored carbon removal, geologically stored carbon or geologically removed carbon, what we are talking today. And this year, 2021, we just plan to make more of all of these steps. So let me tell what is a methodology, what is a carbon removal methodology. So a methodology is a set of rules and requirements to guarantee high quality carbon removal. It sets the minimum bar, the minimum criteria for any removal activity to be eligible and qualify. It also defines how to quantify, how to calculate the amount removed based on the carbon balance within the defined system boundary and over the lifespan of the activity. And then those eligibility and quantification rules are the rule book against which verification happens. So verification assures that the eligibility requirements are met, and the quantification can be validated based on the presented data and evidence that the inspector sees. And I think this is a good place to advertise that if you are passionate about writing methodologies, there will be more of those in Puro.earth. So please send us an email to recruitment@Puro.earth. If we then jump to the eligibility rules that are needed in carbon removal. So let's look at the steps of geological carbon removal. Very simply put, 3 steps are needed. There is the capture phase, then there is a transport phase and a storage phase. These steps all together, they make this carbon removal. And in the methodology, there are requirements and criteria for each of the steps. If we start with the first step, capture step, so the requirement is that the carbon dioxide has to be physically removed from the atmosphere. And there are the 2 options that Mark so clearly pointed out. Direct air capture, or then having an intermediate step in biomass, and through biomass then converting it or transporting it to geological carbon stock. What is not eligible in this methodology is the fossil capture. That is not genuinely removing carbon from the atmospheric stock to the geological stock. If we look closer to the intermediate step in biomass, then we see very big variation there. So you can take carbon containing substance like bio-oil and insert it into a geological formation that is very close to what direct air capture does. It has no other purpose than carbon removal. So it's done only and mainly for carbon removal, negative emissions. But then there are other ways of using the biomass as an intermediate step where there is a co-product, bioenergy. The co-product is the electricity or heat that you generate, and while doing carbon capture or afterwards you take the biogenic carbon and put it underground. Same with the waste incineration, biogas upgrading, or it could be any industrial process that has biogenic carbon dioxide, not the fossil version, but biological carbon in their process, which can be captured and put underground. Then if we look at, if we say that it has to be biogenic, the middle step is biomass. There are also requirements for the biomass itself, and it must be sustainably grown. So the biomass itself has to be able to show that it grows back and the land use changes are not negative. There is no net harm done by growing the biomass or using the biomass. And in the methodology, we lean on the RED II directive, European directive, which is a fresh definition of sustainability of biomass, updated as recently as in 2018. So we have not invented new sustainability criteria. We are building on the existing criteria, which already has reporting and monitoring and verification in place. So in summary, the eligibility rules for the carbon dioxide source are that it can come from directly from air, direct air capture, or then there are the biogenic carbon dioxide variants from bioenergy, waste, biogas, other industrial processes, or then this carbon-containing substances like liquids, bio-oil, slurry, or other substances. Then I would like to move on to the final step, the storage step, and what requirements this methodology puts on the storage. So for the storage, there is criteria very specifically defined both in Europe and in US. The criteria is defined by authorities, so it's regulations and laws. And with that, with those criteria comes also the permitting process that the authorities do and follow. So you can only inject into wells that are controlled and monitored and permitted by the authorities. And here again, we have not invented the wheel again, but we have leaned on and built on these existing criteria. In EU, it is the CCS directive made especially for carbon capture, carbon storing underground. And in US, their EPA controls all kinds of wells. They've made a new category 6 for carbon dioxide wells or injection, but these carbon-containing substances can be then injected also in the other. So there is 6 types, 6 classes of wells defined in the EPA criteria. So that is what we have used as a basis, and if there is similar regulation elsewhere, that can also be used. So in this context, like I said, a couple of classes are allowed for different types from these regulations. So there is a specific class 6 or CCS for this carbon dioxide only, and then there is carbon containing substances can go to class 1, 2, or 5. EOR is enhanced oil recovery, which means that is defined as class 2 in the American EPA standard or regulation. Then the other set of rules in the methodology relates to the quantification, what is the amount of carbon removed or the net amount of carbon removed. So there the principle is the carbon footprint calculation or life cycle assessment based on the activity life time span. And the carbon balance is CO2 stored, netted, deducted with the process emissions. If it's negative, the carbon balance is negative, it means that you have removed more than you have emitted, and that's what needs to be true here. And the system boundary is broadly defined so that we look at end-to-end. The definition is to look end-to-end process. Life cycle is the time limitation here. And good to say that no avoided emissions or reduced emissions are included in this or any other Puro.earth calculations, quantifications. So in the case of geologically stored carbon, there is the captured amount of CO2 as the stock, that is what has been removed, and that is from that is deducted all the project emissions here in the middle, and any losses or leak or venting or fugitive emissions. And here again, we are building on existing knowledge, existing competencies, how LCA calculation is done. It is, there are, the GHG protocol is much older than Puro, has existed 10 or 20 years before Puro, and also ISO standard based on the GHG protocol defines very detailed how to do the calculation of life cycle carbon footprint. So these those principles are applicable to all different variants that this methodology covers, and then there are details that are different for different variants. I've picked here a couple of examples. For example, if we look at the first captured amount of CO2, if the source is mixed carbon dioxide source, so it has both fossil and biogenic, it's only the biogenic fraction that is the is considered, is accounted as the captured CO2 here. So that has to be measured, and that amount is the first blue box here. Similar differences or definitions, carbon containing substance. If it's an oil, you measure the carbon content of that oil, and that gives you the CO2 equivalents. How much does that contain carbon, or how much has it captured stored carbon? And for the EOR plus, whatever fossil oil is taken out from the well by injecting the biogenic carbon dioxide, then you have to deduct that from the stored, captured amount of CO2. So same principles, but different details for different variants of removing and capturing CO2 from the atmosphere. In summary, there has to be one responsible party for the end-to-end capture and storage, so that there is defined CO2 removal supplier, that's the terminology used in the methodology, who is contractually responsible end-to-end. And this responsible person then has the contracts in place with the other ones, so that there is a prime contractor and then subcontractors to the carbon removal supplier. So all of these in summary is that we look at the net CO2 removal, where the carbon dioxide is captured from the atmosphere and stored permanently by a CO2 removal supplier. And the CO2 has to be direct air captured or biogenic. And the storage, permanent storage, is geological storage. And this one responsible party end-to-end is an important concept. I would like to thank you, the work group and the work group members. This work started in the fall. We had meetings with these members presenting the different variants of this CCS types, carbon capture and storage types. And we had, in my opinion, very good discussions. And what was especially eye-opening for me was that when we put together these experts of different areas, we sort of took a helicopter view of the carbon capture and storage technologies and harmonized, made them comparable on next to each other, comparing different things, putting same requirements, same boundaries for different types of carbon capture and storage. I think it was really eye-opening for me, very good to see the differences and as the common nominators. And I was really pleased with the expertise that we had been able to summon in the room or in the group. And an example of the discussions, we did understand that it is trade-offs that we are making. So there is no black and white, right or wrong answer to actually any question that this group discussed. Here is an example of the equipment discussion. If the system boundary has to include the manufacturing of the equipment and the construction of the facilities for carbon capture and storage. And the red opinions in the discussion showed that it's not really significant. Maybe it's not even required by the buyers. The gray opinions pointed out different aspect of it, that it is actually quite hard to calculate. And if it is calculated, there needs to be rules for amortization, and it may take very much time to come to a real figure. And then the blue section talked about the completeness, that actually all emissions have to be in the balance. And in the end, the methodology today is actually the blue opinion, that everything is included. But we've taken the gray in the way that there is a definition how you can do it easier with the help of a capital expenditure. So not maybe looking at all the details. And also the red opinion is taking into account in the sense that if it is less than 1%, then it can be omitted, like it is in all LCA calculation rules. If something is insignificant, then you don't have to spend time and effort in calculating it. So this is, how very different aspects and opinions surfaced when there were different representatives in the group, and how the consensus formed not through voting, but through taking these different aspects into account. I was really learning a lot and very pleased with the discussions that we had. In summary, the methodology defines geologically removed carbon that can be issued in corks, CO2 removal certificates, and 1 metric ton of CO2 removed from the atmosphere, net of any life cycle process emissions, and indeed intended to be permanently stored underground. That is, in very brief summary, what this methodology for geologically removed carbon defines.
Thank you, Marianne. That seems like really exciting work. And I'm sure that in the audience there are some questions. And so we will now go to the Q&A part of the program. We've actually received already some questions. And so we will go over those. The panelists of this part are here. I will briefly introduce each of them and their companies. So we have Jannicke Bjerkas, CCS director from Fortum Oslo Värme, which has developed a CCS project on waste to energy and provides a blueprint for cities across Europe on how to best deal with CO2 emissions from non-recyclable waste. We have representing direct air carbon capture and storage, Brett Cooper from Southern Green Gas from Australia. It is a renewable energy company pioneering technology for carbon neutral fuels and for generating negative emissions via direct air capture of CO2 linked to geological storage.
Brett, can you put on your camera now? And maybe all the experts could then turn on your camera. Go ahead, Elba.
We will also have representing BECCS, Dr. Fabian Levihn, head of R&D at Stockholm Exergi, which is the city of Stockholm's energy company. They ensure that the fast-growing region has access to heating, cooling, electricity, and waste processing services. In 2019, they opened their first research facility for bio-CCS. For storage, we have Christel Lampton, technical manager at Northern Lights. This is a project which is part of the Norwegian Longship project with the ambition to create a complete carbon capture and storage value chain in Norway and in Europe. For enhanced oil recovery plus, we have Esther Mertens, head of European projects from South Pole. South Pole is a leading climate solutions provider and project developer with over 400 experts in 18 offices worldwide. We also have Camilla Brox from Borg CO2. Borg CO2 is a Norwegian company established to facilitate and manage studies on carbon capture utilization and storage. They have a long-term goal of building an industrial CCUS cluster. Welcome to all of you. If you could, like Marianne said, at least put your cameras on, though I'm not sure if in the recording everybody will show. But what we will do is that I will go through the list of questions that we already have, and then also anyone in the audience can start putting questions in the chat. Because if we have time, we will also choose some of those questions which are related to the methodology. So I would like to start with Brett, Brett Cooper from Southern Green Gas. We have a question that was sent to us. It says, direct air capture is very energy intense. It takes very much electricity to capture CO2 from thin air. How can DACCS be net negative? How are you able to remove more CO2 than you emit when all energy-related emissions are counted in the balance?
Well, thank you very much for the question. The first answer is that we're going to use renewable energy in the form of solar power to run our DACCS units. Australia has a unique situation where we have some of the best solar resources in the world falling on very large areas of non-arable land where we can deploy our DACCS capture units. And these sit over the top of some of the best geological storage sites in the world. This makes it possible for us to collect electrons very, very cheaply and turn them into molecules effectively exactly at the same point. So we don't transfer the electricity and we don't really transfer the molecules other than to the injection well. So our costs are very low. Where we propose to do this in outback Australia, we can probably collect electrons in the range of 1 to 2 cents per kilowatt hour, $10 to $20 per megawatt hour. Roughly, we are expecting that it will take about 2 megawatt hours of energy to run the DACCS unit. About 25% is to run the fans that push the air through the capture material, and about 75% is to raise the heat to promote the desorption, that is the removal of the CO2 from the capture material. It then gets concentrated and injected up to 2 kilometres into the ground. Thank you.
Thank you, Brett. So now we will go over to Christel. Christel, I think this question it's right for you. Can you explain how is it possible that a gas remains underground? Why doesn't it escape? What characteristics does the geological formation have to have for it to be airtight?
Thank you, Elba, for the question. When we search for a reservoir to store CO2, we are actually looking for what we would say is a classical trap as seen in oil and gas, which means that we are looking about 2,500 to 3,000 meters below the seabed for what is called a cap rock, which is a structural roof above a reservoir, and some faults which would help sealing that reservoir. The same mechanism keeping currently oil and gas in place for millions of years are actually the same mechanism we see to keep CO2 underground, and they are natural mechanisms. The first mechanism is a structural trap, which means that we have that roof which holds the CO2 in place. Then the second step is the molecule entrapment, which means that the CO2 molecules are being trapped in the porous rock in the storage place, and they act in a way like a sponge, which traps those drops of CO2. The third step is the fact that the CO2, which is actually stored in liquid phase, not in gas, so it's kind of watertight reservoir, not gas airtight. And those molecules of CO2 will dissolve in the water, which is present in the aquifer over time. And then last but not least, there is some kind of mineralization process, because over time, the dissolved CO2 can react with the minerals and bind with the rocks. So, which means that the longer the CO2 stays, the safer it gets. The reservoir characteristics, as being asked, what we need is to have sufficient capacity. So we need to have petrophysical characteristics, which are good enough to avoid issues during the injection and to avoid pressurizing that reservoir. So in order to do so, we need to have sufficient capacity in the reservoir. And something which is important to mention, which was also mentioned by Mariana, is that we will, once the CO2 is placed in that storage location that we have selected, we will, and we have a requirement to monitor both the pressure in the reservoir as well as follow up the CO2 plume, as we call it, which is a CO2 dispersion within that storage. And we do that by the means of 4D seismic, which is regular seismic that we do every few years. And then we compare them to follow where the CO2 is migrating within the storage location.
Okay, thank you so much, Christel. So now we go over to Dr. Fabian Levihn. I think this is a good question related to BECCS. Sustainability of biomass used in BECCS is very important. How do you assure that you only use sustainably sourced biomass? Has the EU RED II directive changed any practices?
Yes, I guess it has changed practices for very many, but not for us. I think the question of BECCS and if it's good or not is of course extremely related to the sourcing of biomass, and I fully agree on that. In the case, if you take Sweden as an example, we don't use any primary biomass for combined heat and power. We use what's normally called slash, so branches and tops that fall due to outtake of wood for pulp and paper, or because we have a need for the board industry, because we need building materials or making furniture or other things out of wood. So in our case, it hasn't really affected us, the RED II criteria. That said, Stockholm Exergi was the first energy corporation in Europe and the second energy corporation worldwide to get this WWF chain of custody certification. So that has been for a couple of years the main thing we work with, having wood that is that we have this FSC certified wood. And if it isn't FSC certified, what we do then is that we do our own due diligence. We send personnel out to look at the worker conditions, not only that the actual biomass is sourced correctly, but also that the worker conditions are sufficiently good, that it actually works in a sustainable way all around. And of course, that will be, I think, extremely important for everyone that uses biomass in the future, because, yeah, I think our perspective is that the only way that BECCS is good is if the biomass also is good. But for us, it has been, I think, a little bit easier than it might be for other corporations abroad, because also Sweden, we have this long tradition of forestry. So 70% of our land area is one forest, basically. So it's it's written into our constitution that you need to replant trees, because forestry is a strategic is regarded as a strategic question for Sweden. So it's written into the constitution that if you take out forest products, then you need to replant trees and ensure the growth of new forest. So of course that makes it easier as well. So, but it doesn't look like that in all places over the world. So it's very different, and you need to have control of how you source your biomass.
Thank you. So now we go over to a waste to energy question. Jannicke, Bjerkas, municipal waste that is incinerated for energy is a mix of different sources. In this methodology, only biogenic CO2 is accepted. How do you know which fraction of the municipal waste is biogenic?
Hello, Ylva. Thank you very much for that question. I'd say, as you say, this waste is used for producing district heating and electricity, but it's used only once. So this means that this should be and is an end-of-line solution for the residual waste that we really cannot recycle. It's not possible to recycle, and that we need to take out of the cycle. And this is a necessary measure in a circular economy in order to be able to close down landfills. And that is the main contributor to methane emissions from waste handling. This sorted and recyclable, not recyclable waste is, as you say, it's a mix of fossil waste, mostly plastics, and but also a large content of biogenic waste. And the obvious and most accurate way to measure this is to measure the C14 isotope in the flue gas. So that is basically a very accurate way of measuring this, and it's easily it's a technology that we have. It's a cost, but it's definitely possible to measure this in a very accurate way. It's also possible to look at the waste mix going into these plants, and in that way set some sort of a standard, but that would have to be done then on a regular basis to be able to adjust the mix as the sorting and recycling is developing. So the C14 content is definitely the most accurate and the technically most feasible solution today.
Excellent, thank you so much. So we have another question. This one will be for Esther Mertens. This one is about EOR plus. So there is a contradiction in EOR plus, or enhanced oil recovery plus. You are pumping out fossil fuel from the well. So how do you explain that this is good for the climate?
Hi, thank you for the question. Great question, of course, because I totally understand the controversion working together with, because I think here the complexity is that you actually will introduce companies like oil companies into the story of climate change, and you can have quite large doubts if this is the right strategy of really going towards net zero. However, if you look at current strategies, each, but especially large polluters, have to set their science-based targets. So we're looking at first avoiding, then reducing, then compensating. So in this case, you have to think that EOR plus is part of the compensation strategy of such companies. So that means that they already have to make sure that they have to first avoid and reduce their emissions. So you have to think broadly and see this as one part of the solution. One part of the solution where companies, and all companies, are encouraged to first look at the avoidance and reduction of their emissions. So I think that's the first answer to this question. The second answer is that Puro is taking a very conservative approach. So we're looking at only removals, of course. So the only removals means that any ER plus operation already has to have more carbon pumped into the aquifer, or to the EOR reservoir, than what they're actually extracting. So that is also very important. And I think to follow also Fabian's talk there, it's also important, and there's restrictions related to what is the CO2 that you're going to pump in. Like, current regulation might not be very restricted to that, but of course, for this case, it's important that this is biogenic CO2. And a third point I wanted to raise is that in the climate solutions sphere, especially for market mechanisms, it's very important to look at low-hanging fruits and options that are actually reasonably financially implementable. So in this case, EOR plus is actually quite interesting solution, where you're close to a very large operation already. So this is one of the largest industry in use already, where carbon is being stored under the ground. So there's quite some research and development already ongoing, and it could be really the first start for large-scale implementation, which can then in the future move to even better, of course, solutions. So that's my answer, short answer.
Thank you so much, Esther. We have another question which might be suitable for Camilla Brox from Borg CO2, about shared storage and shared transport. How can you measure the amount of CO2 that has been stored per different capture operators when the gases are being mixed in the storage and transport?
Well, thank you so much for the question, and thanks so much for having me here today. So Jannicke talked a lot about how to measure the amount of biogenic CO2 from the emitters. And BECCS CO2, we have several different ones within the cluster. So we have a biorefinery, we have a paper mill, we have several waste to energy plants. So for measuring the amount of the CO2 that actually finds place at the source, where the CO2 is captured, and it will then be liquefied and transported to the CCS hub for temporary storage before it gets shipped out for the Northern Lights. So when it comes to the mixing of the CO2, we have not yet in this feasibility study the chance of the measurements actually changing when mixing the CO2. And just to mention, we have a capture potential of 630,000 tons of CO2 within the CCS cluster that we're building, and 70% of this is actually bio-CO2. So, however, the calculation parameters that are provided, that Marianne, you talked about for verification, has taken into this into account. So, for the no emission, the avoidance of the reduced are included in this. So that will be the mixing of the CO2. Thank you.
Great. Thank you so much, Camilla. Now we have some questions there is one question in the chat. I think Marianne could answer that, and then I will have also some final questions for everyone. Marianne, so Hendrik Schult asked, how long did it take Budo and the experts to develop this methodology? What other methodologies are under development, and when are they expected to be available?
Thank you for your question. This methodology started, the work groups started in the fall. I think it was September, October time, and we had meetings throughout a couple of months. And then after that, we have had these feedback sessions one-to-one or in different meetings and constellations, so that people have contributed in improving it and giving in more aspects to be handled. And it does take a few months to do it in this way, and it is still open for feedback until end of this month. Other new methodologies that we could possibly do, they are related to oceans. That is a part that there has been suppliers or providers that can do removal in ocean, either through the biomass or then the CO2 that is already dissolved in the ocean and mineralizing that away with different mechanisms. But also the biomass or the related to the biomass or the stock of carbon in the terrestrial biomass, whether enhancing the growth of that, the speed of growth, or then conserving it in different ways so that it does not decompose anymore. Those are maybe the topics where I think that the next methodology development will happen.
Great, we're very much looking forward to that. Actually, there is Fabian would like to talk a little bit more about the EOR plus.
Yeah, it's just a short comment on it, because I think we see very large regional differences in sort of the opinion of biomass, the opinion on everything. And I think it's good to be clear, because it might be Swedish listeners in the audience reviewing this later, that from a Swedish perspective, EOR is not something that is viewed as okay. So we will never put our biogenic CO2 in for enhanced storage recovery, even if it's cheaper than dedicated storage. But with that said, there are regional differences in the views on what is okay. So if there are other regions where they want to pursue this as part of some kind of efficient reduction portfolio, then it might be then it's not sort of covered by but what we are looking on. But for our perspective, our CO2 will not go to EOR, just so we're clear about that.
Okay, actually, this takes me to one of the questions that I would like to ask to all panelists. regarding the work in the work group. So Marianne, for example, she explained that you had to discuss some trade-offs and then make a decision for the methodology. So how did you feel about that way of working? And if you can raise your hand, or I mean, the presenters can unmute themselves, so you may just speak.
Okay, I guess I can start. This is Jannicke. I think that the discussions that we had was interesting to be a part of, because there were a lot of common issues, but also definitely differences. And as Fabian is now also illustrating, different views on the technology and the methods and so on. And it was, I think, the group was put together quite broadly, which gave these different views and interesting discussions also on the more complex dilemmas regarding system limits and different kinds of measurements and so on. So I think this was quite an efficient way to go through the discussion of the dilemmas and find common ground for such a methodology. Thank you.
Thank you, Jannicke. So if any of the other panelists would like to speak.
Yeah, I think it's been good because we don't always agree. And and this is also something that is forming, and if you don't have disagreement, that's a way of sort of both improving your arguments, maybe changing your arguments, changing your view and everything, which is very good. And I think all of us, still don't agree on everything that has been put up, so which is good. It is as it should be. This is something that is still a growing market and a growing product, and it will probably also be changed and improved in the future. So
yeah, just here from Bologna, fully agree with Fabian said that it's a developing methodology. It's very early days. Ideally, you would have accurate measurements for emissions everywhere throughout the chain, but sometimes those aren't available and estimates will have to be used. So this is a very healthy compromise, and in all likelihood, I expect it will evolve as we find out better ways to measure things.
Yeah, so Camilla here. Paul Mikkelsen joined most of the work meetings. However, we have been very fortunate to be part of this work group and also learned a lot along the way. And we have common goals. We all want this to move forward and to actually make this happen. So we've enjoyed being part of this, and so thank you for that.
Thank you. Well, maybe we can go on also to all panelists. You know, this was first of its kind methodology of carbon removed into geological formations. What is it that you would like the audience to remember about the methodology? Sort of the main points or differences that you see in this methodology. And again, any of the panelists can answer.
Okay, I'll go again. I would actually point out two main important issues, and the first one is the actual sustainability of the biomass, that the importance of that, and the other one is to make sure that you avoid the double counting. Thank you.
Yeah, I'll go second then, Camilla here. I would believe that one of the takeouts here would be also that only the biogenic fraction of the CO2 capture is eligible. That would be one thing to take part. Thanks.
Thank you.
Estelle Lanton here. What I would like to, more generally about CCS, what I would really like people to remember is that it is both safe and permanent as long as it's CCS and not there's no utilization. It's a very low risk process. We have done it for many years, over 25 years, and we have a lot of experience with it. And it's also not an alibi to use more fossil energy, but it's a necessary step to allow industries like cement, steel, waste and handling, which need to be there still in the future to survive in a transition to a low carbon world. And it's also an enabler to develop new energy value chain, like, for example, hydrogen in steel as a low carbon source of energy. Thank you.
Yes, maybe I can continue. I'm still thinking about how we can improve it even more in the future. Because now we talked a lot about the leakage along the way and everything, but for example, if you have combined heat and power, then you can recapture energy from the capture process, getting the energy penalty down to maybe 3%, I guess. Also Fortum, Oslo, Värme, Jannicke are in the range of, or something like that, because you recover all the energy used in the process into usable district heating. And the value of that compared to having other sorts of production where you have higher energy penalties and everything is sort of not included today, and that might be something for the future. I'm just guessing, but that was more about how we can improve it even more. So I don't know.
It's Brett Cooper here. I just like to ask a question actually of Marianne, which I also put in the chat. We follow the low carbon fuel standard program in California as one of the sort of gold standards, and they have a concept there to deal with the risk of leakage by insisting that a certain number of certificates that a promoter can issue have to be kept in a buffer zone, anywhere between 8 and 16%, depending on the perceived risk of long-term leakage. Do you see any similar role for some sort of mechanism in the Puro.earth system? Thank you.
Thanks. Regarding this methodology, that kind of buffer for uncertainties, either uncertainties in the measurements or uncertainties in the sort of the permanence or durability were discussed, and a little bit in the line like what Crystal just said, the uncertainties in the measurements were considered to be really small when it's industrial equipment that, I mean, the measurements themselves are not new. So there is a requirement to have the equipment, measurement equipment calibrated, and the calibration is verified by the inspector. And when it comes to the durability, then I think that the risks here are considered very small. So that is maybe a question that we have to raise with the buyers, that what kind of buffer or insurance do they think is needed based on the security and safety of these injection wells that the authorities are monitoring.
Okay, thank you so much, Marianne. We do have another question in the chat, and perhaps this could be answered either by you or by Antti. It says, you mentioned a pre-cork and an equity fund in the beginning. What ideas is Budo developing to ease the access to capital for project developers?
So I can take that. This is Antti from Puro. We've sort of seen that there is definitely need for further rapid growth, and instead of growing 50% or 100% a year, there would be room for 10x or 100 times bigger facilities that we have at the moment and or in our ecosystem. It's just that some of these processes are difficult to comprehend for the traditional finance, let's say, institutions, and therefore we've tried to make it as easy as possible, and we start by creating a new type of a let's say securitized way of selling sort of future production of negative emissions. And related to that, once we've got these sort of long-term offtake agreements that are structured and formalized, it is likely to be easier to raise equity funding that is needed then in order to get sort of debt to cover the rest of the project. So this is a framework that we are in the process of developing, and happy to discuss this in more detail as it is being developed. Happy to get the feedback to that. We are looking for also investors that would like to invest in this fund. We are trying to make it significant in size. So looking forward to this journey. We are in the early phases of that, though it's good to say. But we start practicing in Q2 with at least one case.
Excellent. Really looking forward to that. Thank you, everyone, for such a great session. Thank you to all the panelists who were in the work group. Thank you, Marianne. Thank you, Mark. I think that one last question for Mark would be, at the beginning you presented the definition of carbon removal. Does the methodology reflect that definition, in your opinion?
Yes, I would think so. The point that Camilla mentioned, to remember that only the biogenic CO2 that is captured is considered as a removal. The way that it includes the capture process, the transport process, the storage process, the upstream emissions from the biomass. So I think this fits in very nicely with the methodology. And yes, having to somehow manage the risks, as Brett mentioned, that might need to be developed further in future. Maybe not necessarily for this process, but for other processes, there will have to be some way to address reversals. So overall, I think that it fits quite nicely with the principles. Yes.
Great. Thank you so much, Mark. I will put in the chat a link where you can provide feedback to the methodology and also where you can download the draft of the methodology. So this is a page in our website. And at the bottom of that page, there is a section on public consultation. And there we invite you to download the draft of the methodology and also to submit your feedback. There is also a link for the feedback form.
Thank you, Elba, and thank you for hosting today. I have the same call for feedback in the last slide if you are seeing my sharing. One reflection I made during this presentation is the nice amount of people or women in this context. So I could almost say that carbon capture, geological carbon removal is female dominated. So thank you, Camilla, Kristel, Esther, Jannicke, for being experts in this area.
And if I may say just a final word on my behalf, there will be another seminar, or sorry, a webinar taking place on Friday, tomorrow at noon European time. So it will be discussing this topic from the corporate perspective. If you have people who are in your organization or you yourself want to understand how to use corks, how to acquire corks to reach carbon net zero, you are very welcome to join. You will find that also on our website. On the top, there's a banner that takes you to the right place. So Puro.earth.